What is up, VOD people? And maybe the one person that pops on early. How you doing? My name is Chad, at Metalhead Maker on most socials. Today I am trying to wrap up the process of assembling my 3D printed high-tech guitar. There's a lot of steps involved tonight, and I don't really have a point A to point B way that I plan on getting this done. So I am going to basically be shifting around here. I've got a bunch of cameras set up in a bunch of different locations, and I'm gonna just kind of try to jump around and make sure that I don't forget about you guys in the process. I will be working a lot with my hands, and it'll be a little hard sometimes to actually see the comments as they come in. So if you guys have comments, I appreciate it if you're patient with me while I kind of try to keep an eye on those, but I might miss one or two here for a few minutes. So I will get moving on this here and we'll get started. So right now, I am at my main desk. Right behind me, I've got all of my stuff set up that I can start kind of putting things together and get an idea of what I plan on doing for the evening. And let's see if we can just get some things going here. Bear with me here. All right. So let's jump over to the main shot. And this area here, this is all the contents of the guitar pretty much. I've got some other stuff here for another project, but pretty much I've got to get all of this kind of stuff put together. And if we take a look at it overhead, this is the top of the guitar. This is covered because I've pretty much shared every part of the build so far, and I want to leave like, one small thing that I haven't really revealed until the end. So that's why the tape is on there. But other than that, I mean, I don't see any reason why I shouldn't be able to get all this together and functional this evening. I mean, I've basically got everything working already, but what you haven't seen yet, and I'll try to see if I can get this together, I've got a new video coming out shortly where I'll talk about this a little more, but I actually completely redesigned and had a new PCB remanufactured. And this one is a lot more stable than the first version, and that's not a surprise. I've got everything tested here. The only problem is that I think I once again fried a few pins on the Teensy because of silly problems that I had while I was testing some other stuff. So I think really what ends up happening is once I get a stable version of this PCB, whether I use this in another guitar or not, at least I know what to watch out for, and I won't have to worry about burning up microcontrollers so much. But as of right now, I mean, that's kind of what I gotta contend with, is the unknowns, and testing stuff doesn't always go quite as smoothly as you would hope. So that said, probably a good way to get started on this would be to kind of take stock of what we have to put together. And let's start with the body. So we've got the outer shell of the front, and you can kind of see that this is only half of the guitar. The underside is the full body that carries most of the electronics, actually all of the electronics. Now this is pretty much done, but there is definitely a little bit more bolting down and gluing and stuff like that. So I don't want to consider this the single last time that I put everything together. I just want to make sure that I can fit everything and that this thing is totally functional before I maybe just, rip it apart and lock everything down. So that's the goal. And then of course I've got the neck with all the wiring for the LEDs. That should be ready to go as well. And then I have some panels that I might go ahead and install in the front body that handle some of the LEDs. I've mentioned that before. This is going to have some LEDs in it. but we just want to make sure that those panels are functioning. I don't necessarily need to have them installed on this part of the body. I don't know. Depends on how tonight goes. If I end up making good progress and you stick around till the late hours, maybe I'll turn those on and get a little sneak peek of what's underneath this tape. I don't know. We'll have to wait and see. All right. Now, this is the slow spot. From here until I can actually start assembling things, I need to just take some time and give myself a chance to kind of get in the groove of what needs to go together in what order. Because I've got a lot of stuff here that is already done. You know, I've got the power routed. That stuff is all ready to go. The battery's already routed there. I've got the pickup wiring and everything done. I need to get all of this in here, and I'll explain what each of these components are. And then I need to get all of the neck wiring done. So I think we're going to start by just trying to get the main board fit into the guitar. So what we've got here is, these are all my test motors. Now, if you have been following the project so far, this guitar, God willing, Odin willing, I'm going to have motors that will tune the tuners. That I still have to build the structure around that and work them into the tuner. So I need to actually disassemble tuners and, you know, spend some time testing and finding a good way to make all that work. But all the electronic functionality is here. Now, knowing that, I need to pull these out because obviously this won't reach all the way to the tuners. This was just for proof of concept. And I will just go ahead and say it right up front. Only 3 of these are working right now, and I believe that is because during those hasty moments I burned out a few pins on the Teensy microcontroller here. That causes some headache when it comes to testing things. I have been able to sort of move some wires around temporarily to test to make sure that the motors are working fine and the board seems to be working fine, but I've isolated the problem to either being directly on the microcontroller or possibly in these 3 little motor drivers right here. So it really just depends on whether I mucked up something on those motor drivers and those teeny tiny little pins didn't get soldered correctly, or, you know, if I actually burned out those pins. But the control board, this is a replacement of what I had previously. So let me grab that previous one. I've hacked it to pieces a little bit because I needed to borrow some parts, but this was the original one. And while the front kind of looks similar to this, I have upgraded a couple components in here as far as the buttons and controls. And then I've also completely redone the control board PCB. On this version here, this was all just hand soldered onto a prototyping board, and it was super messy. On this one, this is a PCB that I had manufactured, and while I did have to do one little tweak because I had 2 wires crossed on each one of the buttons, everything else seems to work great, and I was even able to fit a pretty large screen compared to the first version, so I'm pretty happy about that. So next up, I need to also handle the wire or the lighting and everything. Here are my test strips. These are basically just LED strips that I can use to make sure that the LEDs are firing properly from the board. And lastly, just in case I wasn't quite clear about what we're doing here, this board I fully custom built myself. I had this manufactured and I designed it. It is basically, think of this as like the main board of a computer, but for my guitar. It's going to be handling LEDs, it's going to be handling guitar tuning, and it's going to be able to handle guitar processing, which I'm not doing in this phase. I'm going to be pushing that off to a later phase of the guitar, or some kind of later project. But as of right now, the idea is that we just want to get a function complete product that I can then turn around and continue to develop on until I've got something that's really stable, and then we'll see where the project can go from there. But at the heart of it is the Teensy 4.1 microcontroller. And this is a development board. In a production style product, something like this would not be on there. You would have these microcontroller ICs, or integrated chips. These would be all integrated onto the board itself. So you wouldn't have something that just plugs in like this. But effectively, it does the same thing. And if you need some flexibility and you need to be able to quickly swap out, your microcontroller, or even use it for something else while you're testing things, this is a good way to go early on. And as you get more comfortable, or as I've gotten more comfortable, I'm definitely toying with the idea in future projects of being able to actually integrate all this stuff into the board itself. So then there's not this big, expensive piece of hardware that sits on top of it. It will all just be parts on the board. Anyway, that's the goal. So this needs to go right here. It needs to get all plugged in to all these other wires, which I'll explain what all of these are. All right. Let's see what we can do to get things moving here. Considering that I'm at my center desk here, basically I've just got a bunch of different little desk stations set up in my studio that I can work on different types of projects, and sometimes that works to my benefit, sometimes it's to my detriment. It does make it a little hard to do some type of filming when I'm trying to show something kind of in depth like this. So I'm gonna try to toggle some different cameras here to show you guys some different angles. Let's try this one here. Ooh, that is dark, isn't it? That's better. Perfect. Okay. So if I take this here and I get it all connected, I should be able to just kind of plug it in and get a working model before I actually screw everything down, which is, I think, the smart way to go on this type of setup. I don't want to get everything locked down and find out that, something's going awry. And I think I'm going to get the neck out of the way because I'm just waiting for me to just not realize and push it right off the edge. Might see if I can get it a little bit closer. Some of this stuff is a little hard to film when it gets to when it comes to the tiny, tiny parts. We'll see. Yeah, looks like that should work. Cool. I don't know how I feel about this one here. This wire is like way too long. This is what connects the guitar jack to the board. I might cut that a lot shorter in the final version. I'm going to leave it how it is for now, but I don't expect that it's going to stay that long. Just the longer the wires, the more chances there are for some kind of interference. I also have to put down all of the shielding, which I haven't done yet, which who knows, I might do that tonight as well. And this is for the pickup. This is just for the pickup signal, I should say. It is an active pickup. It's a EMG 81, but it needs power, obviously. I'm not running a battery in this. Flipping it over carefully. All we're doing is running the volume knob here, and then all the power runs out through the other side here and into the board. So we're pulling power from the board. I have a suspicion that that's going to be a mistake, but who knows? We got to just try it. Thinking. So this is for the volume knob. Is it? No. Yes. No. No. Do I have these backwards? Oh, wait, no. I think this is actually, this might be for the power. See, this is why I don't plug in power until I'm dead certain that I'm good to go. Let's see. Okay, so this right here, this live floating wire is floating like that because I've got this covered up. I don't want to connect power to anything, but eventually that is going to get connected, I believe, onto this terminal right here. So yeah, so this is actually the pickup. Okay. This is the guitar pickup power. That's what that is. So we've got the USB, not just power, but also digital. So that means that I can run the USB signal from here on a computer and program this without having to take the guitar apart. It also has USB PD built in, and in case you're not familiar, USB PD is a protocol that allows you to plug this into a USB PD box or power supply, and it allows you to or it allows the system to just decide what voltage it needs, and then it can pull that voltage in whatever appropriate amperage that it's requesting. That's the layman's terms explanation of it, and that's important because I need this board to be pulling more than the standard 5 volts, which is what a lot of this runs on. Basically, this is supposed to pull in 12 volts here and then route it down to 5 volts for a good portion of the higher amperage pulling devices on the board, and then down to 3.3 volts for the 3.3 volt components. Those things are kind of like the screen here and the buttons. Those are 3.3 volts, and a few of the sensors. Now, I haven't spent a lot of time with it, but the little chip right here is a chip that I've been having some problems with. I haven't been able to get 12 volts out of it. Basically, you can add some jumpers onto this to add positive or negative values on that, two different pins on that chip, and it will give you a different resulting voltage when you give it a USB PD signal. Problem is that I can get 9 volts just fine, which is actually maybe exactly what I want, as opposed to trying to do 12 volts, with the pickup here. But it's at the cost of not having the 12 volt power that I expected. So I don't know what that's going to do to the amperage that's pulled. Well, I mean, I do from math, but as far as how the board's going to behave, and also I've got all the markings as 12 volts and everything, so I don't know if that's going to matter. I'm just kind of winging it right now. So yeah. I think what might be a good idea is before we go plugging in a whole bunch of other stuff, even this, let's unplug this. I might just plug in some power to it and see if we can get, let's see, see if we can get a guitar signal to run from the pickup and just make sure it works, yeah. So I've got a little chintzy amp over here. Okay. Sometime I need to talk about this amp because I've had Meza, I've had all sorts of very nice and expensive amps, and this thing has come in more handy and been used more than any of them, and it is the crappiest amp ever. It's one of those little Line 6 spiders. I got it for free, and I never considered myself a dumpster diver or anything, but I was driving by a house in my neighborhood and they just had it out for free, and I was like, yes please. So I brought it home and works great. I just got to find a guitar cable. Oh, where are you? Well, I had a cable pre-wired here. There it is. Cool. So I think I'm going to, nope, wrong one. Yeah, I think I'm gonna go ahead and connect the power now because I don't see anything on the board that looks dangerous at the moment. Really, I'm looking for anything that is connected wrong or anything that's touching, like if I had a pin here that was touching something that it shouldn't, that could cause some problems, but I don't see anything. So what I'm going to do is I'm going to disconnect the microcontroller as a safety and get power going to the board, and then I will decide if I want to connect the microcontroller, if I'm ready to. So we're going to connect negative. Well, actually, let's do positive first. Get in there. So originally, in case you haven't been following, I had this whole guitar pretty much put together, and I had a different board than the black one that I'm working on right now. It was a blue board, and that, you know, I built it in the same way, but I just found so many bugs that, and by bugs I mean, you know, screw-ups that I had when I was designing it, that I needed to get it remade again. So I had it sent away to get it remanufactured, and now it's come back. This new board basically looks the same, but without all the defects. Well, there are a couple defects still, but without all the glaring defects. And I just need to basically go through the process that I did before putting it all together. And if you've been following my videos at all, you've probably seen all of the times that I've had this thing together and removed. So that's fun. But I'm definitely not getting this no matter what manufactured again. I will deal with it if I have any funny quirks about it, and a lot of times if you need to, you can actually use a razor and cut traces and reroute things manually, as I did with this one right here. So you can kind of see that I had to add some resistors right there, and it's not pretty, but it's still a heck of a lot better than dealing with something like this, where you've got all these chaotic wires and complicated manually soldered boards. Oh, it's terrible. Okay, so that's on. So basically, I've got this switch here I can use to turn it on, and that's just pulling power from here and going into the board. I'm just going to do a sanity check, negative, positive. That's plugged in right. So that's the pickup power. This is the out to the jack. This is the volume. And basically, if I turn on the power, I believe nothing's going to happen until I put the microcontroller back in. But yeah, I mean, basically, if I turn on the power and nothing blows up, then I can move on to just doing a quick test on the voltages that are running to the microcontroller. As long as that's good, then I can plug it in and continue on. So here we go. All right, so this is the button. Plug it in. So cool. So we see 3.3 volts is good, 5 volts is good. These little indicators that I soldered on. The battery is good. So that's basically saying, yes, I'm getting power from the battery. I'm grabbing my multimeter now. That needs new batteries. And we're just going to do a quick test on voltages. So I expect to see 12 volts over here. These are little test pads that I added. All right, 11.74 volts, that's fine. That just indicates to me that, yes, it's working right, and I've lost a little bit of voltage from just testing so many times. I haven't really tried to recharge the battery, but I do have a battery charger built into this unit over here. Oops. Then I just want to make sure that I am getting 5 volts where I expect it, which is over here. Ah! This is how I get into trouble. 5.01 volts. I like it. Good, good. Now I want to make sure that I'm getting 3 volts where I expect it, which should be right here. Yes, that is awesome. Looks very healthy. Let's do one more test here. I need to get a little probe. Let's just drop this on here. So I need to get into this pin right here and make sure that we are seeing the proper voltage there, because this is how I burned out at least a teensy or two, is by not taking the time to check the voltage going into the microcontroller. So there's 5 volts there. That's the input voltage to run the microcontroller, and that's what I expect to see. Here at 0, good. Now, as I do this, I will run into a few pins that are that should be somewhere in the range of 3 volts-ish over here and over here, but I just want to make sure that we're getting the proper voltage everywhere else first. This one is not giving me voltage, and that's good and bad. Good in that there's no traces that would give me 3.3 volts, but that actually comes from the microcontroller. I have a diode here right over on this side. This diode that I don't have connected yet will allow me to combine the 3.3 volts that's coming from the power source that I've stepped down with the 3.3 volts that are coming coming from the microcontroller, and that will give me a higher level of amperage that I have to work with on the 3.3 volt rail, because this one over here just doesn't give me that much, since I'm using what's called a voltage regulator, and they just can't push very much current. So just want to quickly just make sure that I'm not seeing any 5 volts on anywhere else except for that one pin. So what I did on the last time that I burnt out one that I haven't even mentioned to anyone yet is I just offset all the pins when I plugged it in. So I plugged the whole thing in one too many this way, I think. And in doing that, basically it shifted everything that way, and everything was fine except for a few pins that happened to be connected to a dangerous source. So a voltage that it wasn't expecting on that particular pin. And those pins, I think, are suffering right now. They're behaving oddly. Like, I don't have analog on some of them, but the digital still works. So that tells me that there's probably part of the MCU or the microcontroller processor, it's burned out. Okay, and we're good. We are solid. So I'm going to turn off the power. That fades slowly because we got such a honking huge electrolytic capacitor. So this time I'm going to make sure I line these up properly and don't offset it. I got to put some kind of like restricting pin thing there so I don't accidentally do that again, because that's what caused it. I just wasn't paying attention. It was down one too many. This needs to go into here eventually, because this is what allows me to connect to the USB source from the outside of the guitar and program it. But I don't need that just yet. I just want this to be on. Now when I plug that in, matter of fact, I know I just plugged that in, but I'm gonna pull it off really quick. I noticed that I hear the relay. This relay basically turns the guitar signal on and off from the pickup. And I hear it turning on, which makes me think that I might have it pre-programmed where it's on immediately. And if that's the case, that's good, because we don't have to have the microcontroller installed, so I can just try to turn this on and get some sound out of it. So let's turn the amp on. It would help if I had it plugged in. Okay. Why are you not plugged in? Prepared? Me? Ever? No. Cool. Okay. Supposedly the amp's on. Let's make sure we're getting something. There we go. All right, I'm guessing you guys can hear that. Well, I think that's just because it's not on, so it's not, power isn't grounding it. Okay, so here we go. Okay, so as long as the power, or as long as the volume's up, oh, look at that. Cool. All right, so that part works. Test 1 is done. That might seem like a silly little test and not that big of a deal, but I mean, getting audio from the guitar is kind of important, and the ability to have all that audio running through a relay, to have that relay turned on programmatically and have all that just kind of work. I mean, that's that's progress. So what's going to be interesting is, you know what, I'm going to leave that plugged in. I've got a test script loaded to the microcontroller right now that tests all the components, and a couple things I do want to run is, just kind of one at a time, is the fan. In case, I don't even know if I'm going to actually end up using the fan, but in case I do need it, have that, and then yeah, and then the sound, just make sure that it's able to turn it on and off on its own. And that should happen immediately. Yep. There we go. Okay, so the guitar's sound is not turning on and off, which is interesting because I thought I had it set to turn that off right away. So I'll have to look at whether or not that relay is actually behaving. But I do see that the fan was working, and that LED right there is telling me that these motor drivers are operating right now. So really the only thing you're going to see is the fan. Cool. Okay, so I mean, yeah, it's doing what it's supposed to do. Except for that relay doesn't seem to be doing or operating how I expected, so I gotta figure that out. What's up, Phil? How you doing, man? So I think next what I need to do is start plugging in some of these devices here. These are our motors. I think I'm just going to plug in one, make sure it still functions with the guitar together. And then the LEDs as well. These are all just the tests. And once that, I'm sure I'm comfortable with that. I think I do need to come back to the relay and do some debugging on that, but I should be able to still get the guitar completely together to figure out what's going on with that. Hopefully I didn't screw up again. A lot of that stuff is very theory heavy, and you don't actually get to find out whether or not it works just until you get the board built and sent to you and try it. So that's where I'm at. All right, so I'm connecting first LEDs. So this is for the neck. So basically this is representing the neck LEDs. And this one right here is representing the body LEDs. I've just got them on 2 different pins, so I can have a little more granular control. Also, I don't know how much load that's going to take with all those LEDs, and I wanted to kind of split it out a little bit. Even though that we're not driving the power from the pins, we are driving the digital signal, and I imagine that the longer it goes, the weaker it gets. Okay, so same test. We hope that this thing spins, these turn on, this guy spins here. I'm not even going to bother with the relay right now. Here we go. Okay, so this should spin, and it does. Good. Oh, we got some lights. Good, the lights are working. And that should work. Okay. I mean, things are going good. Much better than the other night. I should probably mention, if anyone's watching this and watched the last one, I was totally hung up on why my power section was just all jacked up. I was getting, I had like the whole board was pulling amperage just when I plugged it in, and come to find out, like I spent all night trying to figure it out, and there's a little diode here that I had backwards, and I had to pull it off temporarily to do some maintenance, and when I put it back on, I put it in backwards, and that's all it took. So such is the process. Okay. The control panel, do I want to test that now or not? like I said, I don't necessarily have a direction here. I'm just trying to wrap my head around what I need to do tonight. So yeah, why not? Let's just test this. I mean, this was tough because the screen that I have is a TFT screen that is compatible and shouldn't have any problem, but man, are they sensitive. If they experience any kind of odd voltage from, let's say, for example, if you've got a board that isn't really cleanly run, I just have problems with the screen not working. But, you know, I've done this so many times now that I figured out all the intricacies of them, and I can usually get a pretty consistent, you know, result. So you can see kind of here, it's running through the tests and telling me what's going on here. And that's just a little program that I wrote that that tests all of the components. So really, it's kind of like command line. So yeah. Okay, so that's still working. Guys, everything except for the guitar switcher, which is a big deal, works. That's pretty cool. So I think I'm going to start building. I think what I need first is to lock this down so it's not flopping around. All these wires in here, I need to get those decently routed. This won't be the literal final time that I put it together and tear it apart, but pretty close, so I need to have a plan, basically. I need to grab some screws and some tools, which are somewhere. I think I'm doing M3 6mm to hold it in. This is kind of I would say this is the only like janky thing that I really came up with on this design. Other than that, I mean, it's I try to think through the design and architecture of the whole thing very carefully, but I tend to have a problem with like how to mount things without creating a really complex system where you've got like heat set inserts that have to be a certain depth when you've got a really thin part or something. So in a situation like this, actually these might even be too long, we'll see. But I mean, I just basically came up with a system to where I undersize the holes and I put a screw in, and then basically I drive the screw until it's hot and let it set in, and then, you know, let it cool off, and it works. So it's kind of like a pseudo heat set, but just with a screw and nothing else. Like I said, it's kind of janky, but it works better than trying to come up with some kind of crazy solution for this super thin area of the body. And then the cool thing is once it's in there, the hole has proper threading. No, not yet. See, that's just heating it up, basically. That one will have to do. I think that the rest, I didn't mess with that one, but the rest of them are pre-threaded. Whoa. Okay, let's get a little bit more visibility here. on what's going on. Also, I like the stealthier look of this new board better, because this compared to the old board, I mean, the blue is fun, but I like the red and black scheme here. It's cool. Okay. I don't think I'll put in every screw, but just most of them. See, once you get them in there, they aren't going anywhere. Can you pull them in and out repeatedly? Probably not, but go. What can happen though is, considering that you have to put headers or put these guys on and then pull them off, that can work the screws loose. That's the only part that kind of sucks with this type of design. That's why it's probably good to have all the screws in. Go. Yeah, that'll work. Yeah, that's not going anywhere. Super tight. Sweet. What do we got here? What's next? So, I mean, the wires are really bothering me right now because of the fact that I need to be able to kind of know clearly what needs to be tested still. So I'm going to try to do some temporary cleanup here. Let's see if I can do some zip ties or something. Yep, I'm just rooting through my parts drawers. Like I said, just temporary to get me through here. So this is power, this is power. Kind of try to put them together. And I think I'll probably use this here to very jankily wire these to the wall. Just to keep them out of the way. And I'm purposely not including that other wire right there, because that is the digital wire for the Teensy's USB. Last thing we want is to have that thing running directly parallel to a power, because that is a very sensitive part of the circuit. Oh, it's already looking better. I don't know, guys. I think I might end up pulling that off right there and shortening this, because it's driving me absolutely insane. I guess for now I'll just tuck it to get it out of the way so I can think. One thing I cannot do very well is design when there's chaos. I just completely break down. Yeah, okay, that'll work. I like the pink. That fits the guitar very well. I've tried this part, this USB power source here. I've tried that so many times that I know it's going to work, so I'm going to go ahead and connect it. Though I do have an issue where I don't have all of the cables connected. I have spaces to add an additional ground and an additional power to handle the current that's going to be drawn when the battery is charging. That's when the higher currents will be drawn. And I mean, I don't have another source on this little USB board, USB input board, so I don't know what to do with that yet. I got to figure that out. Basically, I think that if I can just maybe tee off another line from one of these, or if when I rebuild it, use a different one or something like that, so I can have more points of contact for the power. That would be helpful. Okay, so there are 2 screws that go in this, and I've got to find them. There they are, found them. That was quick. Yeah. Cool. Okay, so that's locked down. This makes me a little nervous, having this over top of the input button, but like, problem with off-the-shelf parts like these buttons and this this little circuit board here with USB is that they are all in themselves naturally bulky. When it's not built into the control or into the PCB itself, or somehow, you know, customized to fit the space, you have to deal with these little constraints. And when you're, you know, in a spot like this where this is where I need it to be, but I also have to take into consideration the fact that I don't want to go too far out here because I don't want to make these walls too thin. It's hard to make them fit. That makes me nervous, but we're just going to have to kind of watch it and see if we get any kind of rubbing, or if it stresses those wires. Okay, so that's plugged in, that goes there. In theory, just turning this on, everything should still work. And it does. We should see the motor light come on here in a second for the test. Yep, when we do. Okay, we're still in good shape. Next, we really need to start this wiring. What's killing me is that I have a new design for this that I've done since I built this that does not rely on this really sketchy wiring here. It actually uses pogo pins through the center of the bottom of, or the heel of the guitar neck, and will connect here with absolutely no wiring additional other than just the wiring to come up to here. So basically, or sorry, it's right here. So that means that when you push this on, it'll connect the wiring and will not need all of this mess. But I don't have that done yet. And I'm pretty sure that anyone who's actually interested in this project is going to murder me if I keep on redesigning and don't get some progress here. So I'm just trying to push through. That said, these wires still do need to get properly terminated. So I need to put what's called DuPont connectors on these, which are just little sheathings that go over top of it, metal sheathings that I can use to connect these to pins right here. So this is the main power. Actually, that's already done. And this is for the motors, which we don't even have the housing for those done, so we don't even have to really run those. You know what? Actually, as long as I don't have any broken wires, I don't think I do need to worry about this right now. But I think I will put some hot glue on the back of this, because I do have a problem with this constantly breaking. This wire right here is just really volatile. So I'm gonna hot glue this, and I'll probably just tuck these in through here. Problem with these being disconnected is they have a chance to operate as an antenna to some extent for additional noise, but we're gonna have to just deal with it. Okay. What am I looking for? Hot glue gun. So I've got a hot glue gun that would work better for this. Hold on. Which I need to run and grab. All right. This will probably do. Da, 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 da. All right, let's let that heat up. So basically, I think what I need to do is just get that locked down, and then I can actually bolt the neck down. And really, I don't think that I'm gonna have to do this more than once more, because probably gonna want to pull it off one more time after everything is done and together, just to make sure that if there's any last minute things I want to lock down, it's I clean that up first. And then I can call it done from a mechanical perspective and start doing all the real programming and the finishing. Oh, and then obviously the tuners as well. Come on. You know what? While we're waiting, let's make sure that those LEDs work. How about that? I've only got it running like 5 or 6 LEDs as the test, so it's not going to like go all the way up the neck, but it'll at least make sure that is functional. So the stripe, the purple stripe is the 5 volt. Should probably label that. Neck. Okay, so what we expect is just for when I turn this on, just the first few LEDs here should light up. Oh, and we do have marker lights, which is good. See those? And as soon as that turns off, these should start to illuminate. There we go. Wow. Even though I designed this and I've spent many, many hours going through it, I still get amazed when something actually works. I think that comes from so many failures. These wires do not look healthy at all, but it's better this than starting from scratch and having to like resand everything and kind of really think through how everything's going to work together again. It's not that I can't do that, it's just I want to keep the project going. I can always swap the neck out later. That's the nice thing with having this bolt on and not part of the body, or like neck through or something like that. All right, that'll just stabilize this a little bit. Good. So I just need, this is where it gets a little tricky. I need to route the neck through here. This is why it would be so much nicer if I had this pogo. I'm going to complain about this the whole night, and then by the end of the night say, yeah, technically it works, but I'm starting on the new neck now. I know that's what's going to happen. Maybe that'll just be a side project that I keep going when I get tired of this, because it does get a little monotonous. That's what I've been struggling with the most about this project, is even though it's still exciting and I enjoy every minute of it, even when it's stressful, at the same time I do get a little run down from just the amount of steps that are necessary to bring this thing to life. It's very much just like bringing, you know, a manufactured product to life without any kind of gain of being able to sell it. This is just for fun, but man, is it a lot of work. Got some binding up going on here. There it goes. Okay, cool. Yeah, I think that I can probably safely bolt it down now. Now I gotta go find the hardware. Damn it. You're gonna have to stay here for a minute. Let's do a switch on this. Let's switch it up a little bit. There we go. Yeah. This is my just box of junk that I gotta still work through, all specifically for this guitar. Well, except that the parts that I need aren't in there. Where are they? Well, I've kind of made a mess of things. Interesting. These must be them. Something I'm really struggling with right now is whether or not I want to have pristine parts and a very clean, you know, store sale quality build, or if I'm fine with it looking a little more industrially ripped or distressed and stuff because of the design in a nutshell. But I'm just really struggling with that one, because the reality is that, you know, it's kind of a hack thing to just rely on it looking distressed because you didn't take the time to make it look clean. But at the same time, I mean that is the design. It is supposed to look weathered. Oh no, I need those parts. Ugh. Okay, well. Okay. I hate busting out new parts. It's just I burned through so many that these things end up being just abused in the process of building the project. And while it's not a lot up front, you know, these are like, I don't know, $3 or $4 or something like that for these spacers. That stuff adds up really quick, to the point where you realize that you've bought 2 or 3 guitars in the process of just building one. Because, you know, I mean, not only are we dealing with crazy prices right now, but it's also, all these prices are basically retail for the individual price, or for the individual parts. It's not like I get a discount on the parts, which is a bummer. Maybe someday. Though, from what I've seen, even like custom luthiers complain about the actual process of selling these things not being really enough to pay the bills, because after you pay for all the guitar parts, even at cost or whatever they end up getting on their bulk discount, it still, you know, ends up a couple $100 per guitar, and then they only can sell a guitar for, let's say, I don't know, you know, 800 or something like that. And it's just not, it's not lucrative in any way, shape, or form. Actually, we need one more screw. So one interesting design point that I have on this guitar that I haven't seen on other guitars is that I have a 5th screw on the bolt-on neck, and that is on the interior side where it meets the body. I'll show you. If I can get this extra screw here. Where'd you go? Well, I just had it. I guess we got a new one. So, unlike most guitars who have these 4 screws and then that's it, I noticed that there was an alignment problem with the neck where it wanted to go like this or like this, depending on how well I aligned everything early on. And I thought it would be nice if we had a screw that pulled it to the edge of the body from here in this direction, and that would allow me to account for that, you know, angle of the neck. And actually the screw's already in there, so I didn't need it. Just need to lock it down. So screwing this in helps with that alignment quite a bit. It's kind of hard to get going, but once it's going, it's good. There we go. And the more of these types of guitars that I design, the more I'm thinking that that's going to be a mainstay design, because it just works so well. Just knocks out a serious problem without any additional thought. But I do, because of the angle and everything, I do have to use a small little screwdriver. I guess I could get a real long one, but this works just fine. Okay, so that's in there. So that pulls it really up onto the core body. So now when I lock these down, I'm reasonably confident that the neck is going to be angled properly. I'll just get a screwdriver to tighten these down. Of course, I'm not locking this down like it's never going to come apart again, but just enough to feel confident that it kind of behaves as a one-piece body. Okie dokie. So that's done. It's kind of looking like a guitar, which is neat. I guess knowing that we're getting ready to assemble it, we can go ahead and put the control panel on. When I put this together, I'm assuming that I'm not going to have any fitment problems, but I have had issues where I, at least on different versions, where something hit, like that little screw or something. I'm just hoping that it'll work. I've never even tried it. As a matter of fact, I know for a fact that I need to redesign it one more time and pull everything down that way about 3 millimeters to even everything out with spacing, but hopefully this just kind of slides in. Ooh, come on. Oh, it's tight. Yikes. Oh, there it goes. It kind of just worked. I'll take it. Okay, now as far as orientation for these pins, I just kind of know I need to mark everything. I have not marked them, and that has got me into trouble in the past, so I need to stop trusting myself. You know what? I'm just gonna move this a little bit. I want to keep this digital line for the USB as clean and separated as possible from everything else. So I don't want it to really be right in between all of these little signals right here. So I'm going to take this guy and kind of keep it over here. Okay, that's good. These right here, there's not much I can do about it. Let's go back to this cam. There's not much I can do about this mess of wires here because they do have to be there for future state. I think I might just kind of pin them and tuck them for now. Yeah, that's what I'll do. Yeah, that's fine because they're not connected to anything, but I don't foresee leaving it like this for long just because I expect to see some problems with the antenna effect with all these wires just sitting out here loose. Basically, EMI becomes a big factor when you're dealing with any digital signals, meaning signals that are being turned on and off repeatedly very quickly from a microcontroller. Loose wires, especially if they're plugged in to a board but they're not, somehow grounded or terminated, those can be a serious drain on the stability, or rather, and put it in more layman's terms, it can produce a lot of noise in the pickups. I shouldn't say layman's because that's not exactly a rocket science thing, but you know what I mean. So is this enough slack? It is not enough slack. A little bit more. Dumb stuff like this is why I've been building this for over a year. Just because there's so many little decisions that you have to make, and just building things requires so much troubleshooting and trial and error that it is definitely not plug and play. Come on. Okay, cool. Is that enough slack? No, still? Okay. Yay. Okay. So let's get these kind of tidied up and locked down, and I'll try to get them pushed down into that cavity so we don't have to think about them for a while. I would probably be a little more careful with them if they were running any kind of signal, but they are completely disconnected. Okay. Neck LEDs getting plugged in. Okay, fine. That was way too long. Whatever. Like way too long. I don't know how that happened. Anywho. Let's get this one locked down as well. Did I run out of... Oh, here we go. Okay, and if you're just kind of either tuning in or wondering what I'm doing, this is all just temporary. I just need to keep these wires out of the way because it becomes really hard to see what's going on when you got wires strung all everywhere, and without zip tying everything down, they do go everywhere really quick. Let's just do one more sanity check on all the wiring, make sure it works still. Turning it on. Over here in this little button. Okay, we've got lights on our buttons here. We've got some motors. We got a screen that is telling us stuff, so that's good. Yeah, no, everything looks good right now. Woohoo! Let's move on. Yeah, the neck. I'm just looking right now at the bowing of the neck to make sure that nothing has gone funky since I last touched it. It is all 3D printed. In case you guys weren't aware, everything on this guitar is 3D printed as far as the body parts go, including the neck. And it has been fine. So far it's fine. I mean, I don't see anything super wrong with it, but I think I might have, the truss rod might be bending it down a little bit because of how it's set up for when it is together and functional. And because of that, I'm seeing just a little bit of a back bow right now where the fretboard isn't locked down yet, and I can just tell that there's some motion there that I wouldn't normally have if the truss rod wasn't cranked. Probably should have relieved that before I did anything, or before I took it all apart. That's all right. Okay, so tricky part is I can't really lock down the fretboard until I make sure that all the LEDs work, because I know that there was a problem with like right through here. I was seeing some LEDs cut in and out depending on how hard I pressed down on this, which tells me, you know, obviously there's some kind of wire touching or wire getting pulled right there. And since all of this stuff is really kind of encased in resin, that makes it really tricky to identify problems. So I have to make the decision, do I want to write a quick script to just test all the LEDs, or do I want to lock it down? I think I'll write a script so we can move over to my development computer and do that. Okay, since I've got this all connected, I probably should have thought about that beforehand, but that's all right. The guitar fits just fine right here. Fine enough, at least. I'll make a liar out of myself here. I'll make it work. How about that? Let's do this. That's close. Much better. So I need to get a wire run, basically just USB. Oops. And plugged in here. Wish I could get just a little more visibility on this camera. I'm cutting out my usable space on my desk. So this is the nice thing, assuming that this is all hooked up right, of course. I get to plug this in here, and this will connect to my computer, and I should be able to program it. It should behave, but we will see. And I've got a screen share set up, so let's do that. Okay. Very cool. Okay. It's a graphics test. I just basically need to load a test, or load my test that I ran before, but also at the same time just basically test a bunch of LEDs, not just the couple that I had tested before, which I think were 5. So also, it's a Sunday night and I'm drinking an energy drink, and I have to work in the morning, but carpe diem. Where did I put that? Test LEDs, there we go. Num pixels, that's right. Strip dot. Where is the strip defined? So basically the strip, you have to define up front how many LEDs are in each pin, and push this back down. You can kind of see that we've got 5 lighting up right now, but we want that to be, I don't know, we have to do the math real quick. Oops. Okay, so we got 24, oh, so I guess 48 frets, but see, it's not just that simple. It's not just 48. So it's 24, there's bare minimum 2 each. So 24 times 2 is 48, plus there's another, I think, 3 in the middle, plus starting on the 7th fret, there's another extra LED on each one. So that is another 14. So 65. I'm guessing that that's right. We'll go with 65 and see where that lands us. And just looking at this, I see that it is showing up as USB device. So that's what's cool about this that I mentioned earlier. I mean, that might seem really simple that you got a USB port that works, but getting, whoops, let's try that again. Getting USB to come from that little USB pin here, or the little USB PCB, all the way through here, through the board and everything. I mean, that to me, that was an indication that a lot of this was going to work once I was able to get that done. Because it's not just connecting wires. The wires have to be, or traces have to be like the right trace length, and they need to be noise-free enough that you can actually get a signal across, because USB is sensitive to some extent like that. Okay, let's see what happens. I expected once it goes through the motor sequence, it'll go through the LEDs, and if it's gonna break, I expect it to be like right here. If we can zoom in. All right, here we go. So far, so good. I'll point out in case it's not clear on camera if I see any funniness. Oh, you know what? I didn't take into account that the headstock also has LEDs, and it stops. And I don't think that's because I ran out of LEDs. I think it's because there's a problem. And that problem is one of 2 things. It is either that I have an issue with the LEDs on the headstock, or I'm not pushing enough current because it's just connected to a USB, which I can give it more current by just, believe it or not, turning on the battery. So just by turning on the battery, I kind of kick up the current quite a bit. So we're going to turn everything off, turn it back on. That makes me nervous, I'm not gonna lie. When I have to connect this at the same time as this to make sure the extra power draw can be handled. But now we are just waiting to see if we light up all the LEDs, which I expect we're not going to. Oh, or we are. That was the problem. So it's going to stop a little early because I don't have enough LEDs defined, but so far so good. And I think that that is actually, oh, there it goes. Yep, see, there's a problem right there. And notice how it just freaked out. I don't know if that's because the script was at the end or if it reset because there's some kind of like short through. Oh, and it looks like that is a short. Maybe. We'll see. I mean, I thought I fixed it, but who knows? It is nice to see this stuff work after it being disconnected for so long. Because I've spent so much time redesigning all the electronics. Oh, see, it's, yeah. I guess I'll hold this. No, I mean, we're good. We just need to fill it out. It's something like 1, 2, 3, 4, 5, 6, 7, 8. We'll say another 10. It's not like you have to be perfect on this, but it just increases the amount of time that you're counting. So we do have something going on right there, and I gotta get it fixed. I will just hold this down here just to make sure that we're getting a pretty clean test. I hope you guys can see this light. It's hard for me to tell on my little preview screen whether the light's really showing up. I thought I increased it. Let me try again. Did I not? This is what happens when I try to talk and code at the same time. Oh, maybe I just didn't deploy the script. Compiling. Cool. Okay, so now it just compiled and reset. It's going through the motor sequence. It should start the LEDs. Also, I need to figure out how much current is being drawn from these LEDs. I don't have them at 100%, I don't think. Oh, 50, yeah, so I got them pretty low, and I don't expect that I'd ever have them much brighter than this. That's interesting. I don't know what to think about that. What did the script say? The script said nothing because for some reason it's not reading on the serial monitor, which is strange. I think what I'll do is I will speed up the process here. Let's do delay 50. You know what? I'm making things way too difficult for myself. Let's get rid of the other tests. Okay, this should be quick now. Though I am kind of annoyed that I don't seem to have a serial monitor at the moment. Don't know what's going on with that. You know what? That is the opposite of quick. Is it not taking the script? No teensy found. Oh. There it goes. That looks like that works. Okay, that's pretty cool. I need to have a little bit of fun. I've been doing so much of this grueling work that I haven't got to see anything pretty in a bit. Let me change this to be like a, let's do a bright blue. I think this will be blue. Oh, no, 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 cancel, cancel, cancel. This is just RGB, by the way. This is just R 0 to 255, G 0 to 255, B. So more blue than anything. We'll see what we end up there. Let's kill some of this light so we can actually see it. Oh, that's fun. You gotta admit, that looks pretty cool. As a stress test, I will, once I get this thing, you know, totally back together, I'll probably just let it run overnight like this and come back and just make sure that everything's still working in the morning. But yeah, that looks good. I could just like watch that all night. Okay. Oh man, that's neat. Oh, you guys want to see some other colors? I could do some other sequences, but I'd be here all night just goofing around. If we can get a little close up here. We're uploading red now. So for some reason it keeps asking me to press this button. I don't know what the deal is with that. I think it might have something to do with the fact that there's no power cycle since I've got extra power source on it. Oh my gosh, that looks awesome. Oh, that's bright. Oof. Guys, how cool is that? Okay, I want to see it in green now. Look how bright that is. Just shines on everything. You cannot see it on camera, but man, it's shining super bright. All right, uploading green now. Whew. There, that gives you an idea of how bright this actually is. Look at my hands. That is nuts. Okay, enough playing. We've had our fun. Let's take that down. Actually, take it down to 50. Let's do... We'll do purple and leave it at that. So we've got a short here, which I doubt I can make it reproduce, but yeah, earlier it was kind of freaking out when I pressed down on the fretboard. I need to fix that. Oh, there it goes. Yep, you just saw it. Yep, there it is. I'm going to fix that, and then yeah, we should be able to finish locking down the fretboard. Okay. Moving on. I move slowly because I have definitely ripped some cables out of some walls by doing stuff like this. I don't have anything to rest it on. See, and this is why I'm always worried about getting new parts and installing on it when I'm still in development mode, because I tear it up. I just set it on things, I have it upside down, I move it around. I don't know how I would ever do this at scale if I were to ever try to make one of these quickly, or repeatedly, I should say. Let's move over to the desk cam. And we're gonna raise quite a bit here because I need to diagnose that problem with the fretboard. Okay. Sweet. Now that we've got a working fretboard, we want to flip this upside down. Unfortunately, I'm gonna have to cut this because I was a dum-dum and did not pull it off before attaching. This is my hair tie. And this never goes smooth. Pulling these wires, something always goes wonky. Oh. Yep, I knew that was gonna come back to bite me. Well, damn it. I'm gonna have to cut that zip tie. Whoa. Never a dull moment. Am I really doing a project if I'm not constantly dropping stuff and breaking stuff? So what I need to do is get this fretboard completely flipped upside down. And to do that, I've got these wires here in the headstock that I've got some slack made for this, but it's tight. That's an understatement. Oh, interesting. I'm surprised that even worked. I've got a loose wire right here. I cannot believe that I was able to actually get anything past this on the tail end. Huh. Okay, well, I mean, that's cool. Just fix that wire at the end. I really need to get some like super thin wires here, or super thin sheathed wires, because the way that I've got this set up right now, I use, and I do this on purpose, I use wires from network cables because they are usually twisted pair, and they're always twisted pair, and they're usually thin but still able to carry a decent amount of current, so they don't have a whole lot of sheathing on them. And the individual wires are just perfect for stuff like that, but I think that it's just still a little bit too thick for that space. So basically, this is where it gets really space heavy. I need to somehow flip this up like this and over, which is not that big of a deal, but in the process, basically I need a full 2 desk lengths to work. And I could probably spin this or something. Yeah, maybe I can do this, because I'm gonna have to redo those wires anyway, or lock them back down. So I shouldn't worry too much about like breaking them. Famous last words. No, sir, I don't like it. Do I have enough space? Come on. Yeah, I'm good. No, I'm good. I'm good. I'm good. Everything's fine. This is the spot. See, I've already got this cut because I know that I was having trouble with that. Okay, so I need to figure out what is happening, and I know it's on this fret here. I believe it's this particular LED. Something is touching that shouldn't, or not touching that should. So let's get our multimeter. I need to watch these probes. This is going to be the loss of my eyeball. I'm going to go on record and say that if I ever lose sight, it's going to be because of one of these things. Because I fling my multimeter around all over the place, and I do not ever pay attention to what I'm doing with it. And I've stabbed myself a couple times with this, enough to draw blood, but at some point that's going to go in my eye. But then I'll probably have a cool eye patch, so that's neat. That's pretty metal. Okay, so I just want to test for continuity between these and find out if I press one or something like that, if there's a continuity problem. The other problem is that I've got some super glue on this to kind of help everything stay laid down, and sometimes that super glue impedes this kind of work. So we got a little bit of resistance there, which is strange. That might just be the super glue. I don't know. I mean, see that. I mean, this is a ground, so that should be showing 0. And I'm just kind of trying to kick off some of this super glue in case that's what's stopping me from making a solid connection. Yeah. What I'm really looking for is some indication that on the positive here or the negative, before I do anything else, that those are connected okay. This one's interesting already because I don't think there's any super glue on this, and it's kind of bouncing around. Interesting. I'm looking for like, basically we want to see 0 on the multimeter. And we want to see if I'm pressing down on a certain spot, if that happens and then goes away. I don't know what to think about that, because really, this is what we expect to be seeing, right? Oh, quit it. And since all of the power is connected, I mean, that could just, that could just be built up super glue on this line right here. So I'm going to scrape it a little bit. I'm not cutting it, I'm just scraping the wire. Okay. Something going on there. Ah. Haha, I think I found the problem. First of all, I've got a hot glue gun that is still plugged in. That's smart. Man, I'm not going to be able to zoom in on this, I don't think. But this one right here is loose. This 5-volt line. I don't know what happened there or why it's like that, but that is a quick fix, thankfully. Grab my soldering iron. Hopefully it reaches. It reaches enough. Some fresh solder. Just clean up the soldering iron a little bit. Don't ever let your soldering iron get all gunky and ugly and stuff. If that's the case, just know that that's going into your connections. Okay, so this is toxic as hell, by the way. So I've got super glue on all of this. Yes, there's resin underneath it, but the resin is kind of buried. This milky stuff that's on this, that's super glue, and that's going to burn, and that's not safe for me at all. Typically, I would put a mask on and have all sorts of ventilation, and I do have ventilation tools, but for this one tiny little connection, I think I'm going to power through it. Don't try this at home kind of situation. In theory, that's all it should take, but I'm going to heat up that pad really good to make sure that the solder is actually making contact with the pad, not just with the top of the wire, because I think that might have been the problem to begin with, is that the wire had tons of solder on it, but the pad was maybe covered in glue or something. This is a little excessive with the amount of solder that I'm using, but this is like twofold thing. One, obviously I'm trying to make that connection, but I'm also trying to burn through any of the contaminants that are on top of that pad. And the solder kind of helps flow and get that heat to the pad quicker. Okay, I mean, in theory, I think that's done. I'm going to take the soldering iron, just kind of flatten it here. Make sure there's nothing sticking up, because the problem is with this design, there's a lot of problems with the design, but the one that's affecting this area is that this has to be totally flat up against the neck. Otherwise, I end up with high spots on the fretboard when I lock it down, And that results in, oh, I've got one more wire to solder, that's right. That results in some really uneven frets. So this is kind of tricky. I think I might end up super gluing these down, these wires. They're surviving, but I can tell the more I move them around, the more volatile they get. I'm just really tired of fighting these wires, because I've been doing it non-stop since I started putting everything together. As soon, you know, if I moved anything around and then I have to fix something, next thing you know, I've got a connection problem. And then I fix it, get it all back together, have to pull it apart, connection problem again. And that is an indication of a design flaw. Whenever you have a repeat problem like that, that tells you that something is not quite right. And in this case, I don't have anything clamping those wires down to take the strain off of the solder joints. I need this. Basically, I just want to get this all plugged back in, make sure that everything works, and we'll see where we land after that. I hate pulling this tape off because it never sticks right after you pull it off the first time, but I need to move it. It is heat tape though. It can handle it. Jeez, so messy. See, and this is why I think I need super glue. Basically, it's not that I think there's a problem with the connections right now, it's that if I do anything to move those wires, it's not a whole lot stopping them from, you know, just kind of fighting with each other and eventually touching. Yeah, I'm gonna have to put something on there. Hopefully that's the last of the soldering though for tonight. These still look pretty solid. And then of course I've got to find a way to push all that back in and not disturb this too much, because I have the exact same problem on the headstock that I had on the fretboard. So I'm grabbing some super glue, CA glue, and we're just going to we're going to try to prevent from having to do that again. Not going to douse it, just enough to take some of the stress off of those joints. Oh, this one's locked. I forgot. I've got like 3 or 4 tubs of this stuff. Nope, and that one's not even opened yet. See? Here we are. Super glue is such a weird thing. I love it and I hate it at the same time. It can be the most useful stuff, and sometimes it's super brittle depending on the situation. Sometimes it dries fast, sometimes it takes forever. What I think is going to help us in this case is, I don't even know if that makes sense to do. So the problem that I'm having is the wires are crossed right now. So when I do this, things are going to move and it's not going to be in the same state that it was before. So I kind of need to have it facing the same direction and then put the rest of the glue on. There. But basically what I'm doing, it's not that I want to, it's not that I want to really make all these solder joints stronger with the glue. I want to really like lock it down so we're taking some of the stress off the wires around there, and then also I don't want the wires to touch close to the solder joint when they get moved around, and this will help with that. You can do this with like hot glue or other compounds, but the problem is that if you need it to be small, hot glue tends to glob and it's not easy to control. And then this is just an activator to make it dry a lot quicker. There. Pretty straightforward. This should be dried. And I don't like how that's sticking up. I can actually feel that it's, some of that's causing it to stick out, but what we're gonna do is lean this back over, get everything plugged back in, make sure it works before we actually lock anything down. Okay, that was easy enough. Cross your fingers, here it goes. Cool, I think it's fixed. Looks fixed to me. Love it. Now I've got to get these wires fed back through here safely. I'll quit it. I cannot tell you how many times that has given me a heart attack when I'm in the middle of doing something with wiring and then suddenly this beeps at me. Awful. What a jerk. Okay. Need to feed these wires back through so I can get the fretboard back in place. Easier said than done for sure, because pulling the wires through is great until you get right until the end. It's not even a big deal, and then right at the end everything wants to bunch because there's nowhere else for the wire to go. This is why I need another system, something like those pogo pins or something. But I keep going back and forth on this stuff and realizing that every time I redesign something, I have to think about, what am I redesigning it for? Am I redesigning it for this guitar, or am I trying to make a lot of these, or what? And I don't have an answer for that. I just have a tendency to not like things to be half-assed. In there. Now I've got a twist in the wires. There. Basically, there's a channel that they go through, and then there's like a little extra hole that these all can fit in, but it all has to be very accurate, and I couldn't. Oh, there it goes. Kind of just slid into place, sort of. I couldn't really cut out much for the wires, because then you're killing the structural integrity of the neck. Okay, I think, let's flip this on its side here. I think that's solid. Yeah, I think we're good. I mean, I might have to fight with it a little bit. See, the problem that I run into with these things is that everything's just fine, and then I'll have to go to screw it down or something, and that'll put a lot of pressure on a wire and tear it up, which is no bueno. Okay, let's make sure it still works. If it still works, then I can start putting the screws in. And it does. Cool. I think I'm going to take a break. This project is going to continue to be a marathon, so I don't expect to have this completed by tonight. If I have the energy, I might hop back on for a late live stream to just kind of wrap up some of this stuff. But I'm going to have to see how the evening goes from here. And worst case scenario, I do have another video coming out very, very soon, I promise, that is going to cover pretty much everything up to date. I don't like to keep dropping these small videos that give you tiny bits of information about the project. I'd really rather get it to the point where you guys can see some big progress. And so that's what's been taking so long to produce a new video. So let's flip over here. Is that working? Yeah, okay. So, all right, from here, I need to finish putting this together, do some testing. I might actually get it strung up and make sure that it still plays, that there's no structural problems. And then the next time you see me, hopefully I'll have a playable guitar that actually has some level of electronics built into it that are kind of functioning. So that's what we're looking. Guys, if you have any questions, please feel free to leave it in the comments. I am happy to talk to you guys on pretty much anything that you want to chat about. And other than that, I will see you guys soon. And take care.